we're going to continue on for our final video on 6.2 where we kind of bring all these together. And the last thing that we haven't done is using Excel to find a raw score given a probability. So example 5 here, scores on a management aptitude exam are normally distributed with a mean of 72 and a standard deviation of 8. So this is not a standard normal distribution where mean is 0 and standard deviation 1, but it is normally distributed. So we can still use our normal distribution. So what is the lowest score that will place a manager in the top 10%? So let's draw that. We're still looking at a bell curve. The top 10%, so that would be 0.10. And we want to know what score, and it's not a z-score because it's not 0 and 1, it's an x score or a raw score. So what is the lowest score? Now just remember, Excel always gives back the left side. So if we want to type it into Excel, we would type in 1 minus 0.10 to see what score we would get back. And now we're going to be doing the inverse. We have the probability, so we type in norm.inv. Our probability is 1 minus 0.10. Our mean is 72, and our standard deviation is 8. So the lowest score that will place a manager in the top 10% would be an 82.25. Now, we don't know if it has to be a whole number or anything like that. What is the highest score that will place a manager in the bottom 25%? So bottom is over here. 0.25, score X. Well, that's great because Excel automatically gives us to the left. So let's take a peek here. 0.25, 72, and 8. And we see that it is a score of 66.6. So go ahead and give these ones a try. And press play when you're ready to see the solution. And we'll do our last example together before you do 2 more U-tries on your own. So let X be normally distributed with a mean of 2.5 and a standard deviation of 2. So we're looking at a normal distribution, but not a standard normal distribution. So they want us to find the probability. So just a reminder here, if we're finding probability, we're doing the norm.dist. If we're finding an X, we're doing the inverse. So that can be helpful for you just to keep track. That's why we're doing one that's all mixed up. So for A, find the probability that X is greater than 7.6. So we've got the X is 7.6, but we want a greater than. Now remember that Excel gives us this way. Excel is going to give us that way. So in this case, we're going to make sure that we do 1 minus. So it's going to be 1 minus norm.dist. Our X is 7.6. Our mean is 2.5. Our standard deviation is 2. And we always type 1. So we see here that this value here is 0.0054. Now, find the probability that X is between these two values. So we've got 7.4 and 10.6. Now remember that Excel is going to give us the area to the left and the area to the left. So we'll just do the bigger number, 10.6, our mean is 2.5, 2, 1, and subtract it from the area for the smaller number, 7.4, 2.5, 2, and 1. And we get 0.0071. So now it's asking us to find X. So this is different now. They're giving us the probability. So for C, and they give us the arrow. See how that's a greater than? So that's what the direction that you're going to shade. So we don't know X, so I don't know, here, maybe. And we know that X, it's greater than, so it's this way. And we know that this is 0.025. Now remember that Excel always gives us the left side. So this area is actually 1 minus 0.25. So we're going to type in norm.inv because we have the probability 1 minus 0.025, our mean is 2.5, and our standard deviation is 2. And so this means that this X score here would be about 6.42. Let's look at D. So D is a little trickier here. You've done something like this before in a U-try. So we don't know the lower bound of X, right? We want to find it, but we know the upper bound is 2.5, and we know that the probability here is 0.4943. So the thing is we want to find our x value, and so if we use Excel, it's going to give us this area right here to the left, right? So we need to figure out what this area is, right? If we find out this big area, and we can because we know that x value, then we can just say that this is the big area minus 0.4943. So to find that area, we are finding area. So again, even though this direction says find x, before we can find x, we actually need to find the probability. So if I want to find the probability, I know that the score is 2.5. The mean is 2.5. So now I'm thinking here, okay, wait, the mean is 2.5, so I kind of know that the probability should be half, but it's okay. So this here gives me 0.5. So I know that this area from here all the way to there is 0.5. So that means this here is 0.5 minus 0.4943. So that's the area of that, but I need the x, right? Well, if I know the area, I can find the x using norm.inv. So the probability is 0.5 minus 0.4943. And the mean is 2.5, and the standard deviation is 2. And so that means this x value here is negative 2.56. So you had to do kind of a lot of work to get to that point. So go ahead and do these problems on your own. Press play when you're ready to see the solution. Here's the first problem. And here's the second problem. And that concludes section 6.2, chapter 6.